So section 1.5 is solving linear equations. We got a little ahead of that yesterday. We ended up coming across some equations that we were solving, and that just came up in some rational expressions that we were dealing with when we were trying to create rational expressions in the denominator or in the numerator. So we had some exposure to this already, which is just review anyways. So solving linear equations, quadratic equations, and then nonlinear equations. And quadratic equations would be those second order equations. And that famous equation came up the other day, and it'll come up today, the quadratic formula, which is solving for our roots. So solving for a variable or an unknown term in an equation. And so that's what solving an equation would look like. And so we ended up really, like I said, in section 1.4, dealing with things like this. It certainly came up during the simplification and when we were rationalizing. So here we've got 6x minus 5 is equal to 2x plus 11. And so we need to isolate the x on a side. So I'm going to just subtract 2x from each side. And so that gives us now 4x minus 5 is equal to 11. And then to get x by itself, just go ahead and add 5 on both sides. And so doing that would then lead to 4x is equal to 16. And we're not looking for 4 times x, we're looking for x itself. So that means we're just going to multiply each side by 1/4. You could say divide by 4. That's fine. And then you'd find that x is equal to 4. And this also came up. We can check our answer. So you're going to take that expression right there and plug it back into the original equation. And you have to get a true statement out of that. So 6 times 4 minus 5, that's over here, 6, x is equal to 4 minus 5, is equal to 2 times x, which is 4, plus 11. And we get 19 equals 19. So we get a true statement, so we could check, and that tells us our answer was indeed correct. So that last example was a first order equation, right? There was just x was the highest ordered unknown term. Here we've got an unknown x, but it shows up in multiple forms. So it's both in its linear form and in its second order form. So there's just, for this to be true, a has to not equal 0. If it was equal to 0, we'd be solving the problem we just solved a second ago. And so you can solve this, right, in a couple different ways, by factoring or by the quadratic equation. So let's take a look at an example here. X squared plus 4x is equal to 32. And you're asked to solve for x. That's what solve would be. And so to get in the form of ax squared plus bx plus c equals 0, that would be standard form. So I'm going to bring the 32 to the other side. So you got minus 32. And just kind of looking at that 32, you don't want to make it tougher than it has to be, but 32 would be 8 times 4. And we're looking for a 4 when we were to add those numbers together. And so that looks pretty good. We would just use positive 8 and negative 4. So we'd have x plus 8 and x minus 4. So that would factor that equation, right, giving us minus 32. And then plus 8 and minus 4 gives us the 4x. So our two solutions would be negative 8 and 4. And you could then go plug those right back into this expression and make sure that you indeed have gotten it right. So if you plugged a 4 in, you'd have 4 squared, which is 16, plus 4 times 4, which is 16. 16 plus 16 indeed equals 32. Same would be true for the negative 8. You just got to keep track of your positive and negative signs. So the quadratic equation, there's a nifty derivation in your book on page 50. We'll kind of come back to that, but the quadratic equation, right, comes minus b, plus or minus b squared minus 4ac, the whole thing over 2a. So the way that this breaks out for us here is that a is equal to 1, b would be equal to 4, and c would be equal to negative 32. So here's our minus b, so minus 4, plus or minus, and then we've got our radical 16, which is b squared, so that's 4 squared, minus 4 times a, which is 1, and c, which is negative 32. So that's all underneath the radical there. On the bottom, we've got 2 times 1, which is 2. So now it just becomes simplification. So this is going to be, get a little work over here, 16 plus 4 times 32, giving us 16 plus 128, 144. Square root of 144 is 12, right? 12 times 12 is 144. So we end up with negative 4 plus or minus 12 over 2. So those are our two answers. That would be negative 2 plus or minus 6, which would be 4 and negative 8. Exact same answers we got above. And so we can also solve a second order equation by completing the square. And so we would look at the characteristics of a perfect square. So think of it right here of this, right, 1 times x squared plus bx. And if we just happen to have here b over 2 squared, then that actually can be written as x plus b over 2, the quantity squared. Just kind of look at this. If it were to FOIL out, we'd have x squared, right? We'd have b over 2 times x plus b over 2 times x. That gives us bx. And then we'd have b over 2 times b over 2. So b over 2 squared. So that's how we can write the left-hand side. And so the question is, can we get the left-hand side? So let's go ahead and look at an example here. Here's a second order polynomial. We'll divide by 5, right? It's a common factor. So we'd end up with x squared minus 4x plus 2, right? That equals 0. And so we're going to complete the square. So I'm going to take this 2 to the other side. I'm going to like dump it over there on the other side. And there it is. And now I'm going to take this number right here and I'm going to complete the square with it. So I'm going to add to both sides, right? B, which is negative 4 over 2. And I'm going to square it. So that's all I've done is on both sides, I'm going to square it. So that's just 2 squared, that's just 4. So I've got over here on the left side, x squared minus 4x plus 4. On the right side now, I've got negative 2 plus 4. And so then we're just able to factor the left-hand side. And we knew we could do that. That's what completing the square did for us. And so then we've got, right, take the square root on the left-hand side. That means take the square root on the right-hand side. So x minus 2 is equal to plus or minus square root 2. So I can solve for the roots then by just adding 2 to both sides. So I've got x is equal to 2 plus square root of 2, and it's equal to 2 minus square root of 2. So it might be good to, as we're doing this, go either pause, maybe look at your book, right? And we're going to do 1.5. It's going to take us 2 days, but there is the quadratic equation segment. Also the discriminant, that's what we call the quantity that's underneath the square root symbol. And so that's, if you take the square root of a positive number, that gives you a real number. And these are all real numbers. B, A, and C are all real numbers. But if the discriminant is a negative number, then we're going to end up with imaginary roots because you'll be taking the square root of a negative number. So the way this breaks down is that if the discriminant is greater than 0, then we're going to end up with 2 real solutions. If it's equal to 0, we end up with a double root, right? Negative b plus or minus 0 over 2a. So kind of see that right here. If that's equal to 0, then it's going to be negative b plus or minus 0, which doesn't change, over 2a. Okay. If it's greater than 0, then it's 2 real solutions. If it's less than 0, then we have no real solutions, and we are in the imaginary space. So they do a nice job with a derivation on page 50. I think I put another one in the EOC examples. And it shows how if you complete the square on this, just symbolically, divide by a first, and then complete the square, you'll end up with the quadratic equation. So it really proves the quadratic equation. And so let's look at one last one here. How many real solutions exist in this equation? So it doesn't ask you for what are they, it's just how many real solutions exist. So you're just going to use the discriminant to do that. And so I've got an equation right here, 2x squared plus 1. So that's not in standard form. So I'm going to bring the 4x over. So subtract 4x from both sides. And so now I've got an equation that has a proper form to it. A is equal to 2. B is equal to -4. Always remember your negative signs. And C is equal to +1. And so the discriminant is equal to b squared minus 4ac. And so if we just take a look at that, we've got -4 squared minus 4 times 2 times 1. And that's going to give us 16 minus 8, which is equal to 8. So the discriminant is real, greater than 0. Excuse me, the discriminant is positive, which means we're going to have 2 real solutions.